There we go. All right, there we go. Okay, so this is lesson 5.1. And we are going to talk about rational functions and their graphs. And they call this part 1. I forgot to bring my colorful pens, so I'm going to have to work with good old-fashioned black, red, and blue. All right, so real quick, what is a rational function? Well, if you know what the word ratio is, it's a fraction. That's pretty much what it is. Okay, so it's where f of x is equal to some polynomial p of x over q of x, where p of x and q of x are both polynomials, and q of x cannot be 0 because we never want 0 in the bottom of a denominator, obviously. So we're going to go back through all that stuff that we learned like maybe 2 chapters ago about parent functions and transformations on them. And we're going to go through all of this together. So the parent function for a rational function looks like this. The parent function is f of x equals 1 over x. That is your parent function. Now, we can't have the denominator be 0 because at 0 we have an asymptote. When x is 0, we actually have an asymptote. We have 2 asymptotes, actually. We have this one right here, the up and down one, which is your vertical asymptote. That's at x equal to 0. And then we have a horizontal asymptote right here, horizontal asymptote at y equals to 0. So something to write down for the parent function, you have a vertical asymptote at x equals 0. And all vertical lines, remember, are written as x equals. And you have a horizontal asymptote at y equals 0. So all horizontal lines are written as y equals. Then into the parent function, you have these hooks. Okay, you have a hook there in the quadrant 1 and then a hook there over there in quadrant 3. And so you are going to be asked to find, good old things that you know that this whole lesson has been about. You got to find domain, you got to find range, and they're pretty easy actually, because if you know where the vertical and horizontal asymptotes are, then you can easily find the domain and range. So domain, how wide is this thing getting along the x-axis? So this thing is going up until about 0 is where my first problem is. So I'm going to say from negative infinity to 0, 0 to infinity. My range, how tall is this thing getting? Well, again, I have a problem at 0 on the y. So that would be my range from negative infinity to 0, united with 0 to infinity. Okay? And then there's also going to be your end behavior is going to change. Remember, we used to do end behavior with like up, up, down, down, and we make the arrows go up, down. We can't do that anymore. So we say the following. As x is getting more and more largely negative, so as we say, as x is going to negative infinity, as it's getting more and more largely negative this way, like if I were to extend this x-axis all the way to negative, 1,000,000, what kind of y values am I getting? Well, this right here will approach the asymptote of 0. So you'll say, okay, as x goes to negative infinity, y goes to 0. Likewise, the other way, as x gets more and more positive, as I go this way, as x is getting larger, like x is 100, x is 1,000,000, what kind of y values am I getting now? Well, I'm getting really, really close numbers, y values that are close to 0 still. So that's all going to happen. All right, so now that we got the parent function out of the way, let's do some examples. And again, you can obviously use Desmos or your calculator, but we're going to be able to do all of these pretty much without it. State the domain, the range, the vertical asymptote, and they're going to make you do all this on homework on good old MyMathLab. Okay. So we're going to graph y equals 2 over x plus 1, and we're going to state the domain, range, vertical asymptote, horizontal asymptote. So the best thing to, when you have it, obviously, this is your parent function, 1 over x. Now you have a 2. Well, I'm going to rewrite that. Oh, I'm using red. Let me change my color. To be y equals, I'm going to pull the 2 outside and then write 1 over x plus 1. Okay, that's allowed. It's fraction rules. So what does that mean? Let's go over, refresh ourselves. If my parent is 1 over x and I'm inside the parent, what does that tell me to go? If I'm inside the parent, I move right and left. So, and I always go the opposite. So this one, I'm inside the parent. I'm going to go left 1. Remember, if I had like a plus 5 on the outside, I'd go up or down. I'd go up 5. What does this 2 tell me? Well, if that number is outside multiplying by the parent function, like 2x squared or 2 times the square root of x, what does that do? Well, that vertically stretches it a factor of 2. Okay, so now let's give ourselves a little picture here. Here's my original x-axis. I now know that I'm going to shift everything left 1. So whereas in the parent, this was my horizontal asymptote, now this is, I still have, excuse me, I said horizontal, I meant vertical. This is my horizontal asymptote. It still stays the same at 0. So this is x equals -1. This will still be y equals 0. And all that does is that, remember that 2 just makes it kind of go a little bit wider. And you can see that in a graph if you graph it. And so let's answer the domain, the range, the vertical, and the horizontal asymptote. So vertical asymptote has now shifted to be x equals -1. It went over to the left. It went left 1. Horizontal asymptote, it stayed the same. We didn't do anything. We didn't move it up or down. So y equals 0. My domain, I'm going to put a little note right here for you. This will help you. Your domain is up to the vertical asymptote. Meaning, you'd say, okay, how wide is this thing? It's from -infinity. So I'm good from -infinity up until this vertical asymptote right here at -1. Whoops. United with -1 to positive infinity. So up to the vertical asymptote is always going to be your domain. Your range is up to the horizontal asymptote. So that would be along the, how tall is this thing getting? Well, it's going from -infinity up until I have a problem here at 0. United with 0 to infinity. So see, it's not that hard. Again, you can plug this into Desmos and double check it, or plug it into a calculator and look at it again, but it's stuff that you've already done before. All right, let's do another similar problem. Flip this over. This one says the following. What is the vertical asymptote and horizontal asymptote of y equals 1 over x minus 3 and then minus 6? Well, again, there's these shifts that have occurred, and those will move our axes and will create these asymptotes. So again, my parent function is 1 over x. If I'm with my parent, I go right or left in the opposite of what I want to do. So this is minus 3. I'm going to go right 3. I'm going to move. Here's my axis. Now I'm going to go 1, 2, 3. So now I'm going to have my new vertical line is going to be 3 to the right. X equals 3 is my new line. This minus 6, if you're on the outside of the parent, you go up or down. So this one is a minus 6, so you go down 6. So go down 6. 1, 2, 3, 4, 5, 6. That would be y equals negative 6. So this right here is your horizontal asymptote. And that right there is your vertical asymptote. And you can graph it. Your hooks would go here. They would shift. They would now be in this new corner and in this corner. But it didn't ask us for that in this example. But if it does, again, you can plug it in and look at it. It's pretty easy. All right, then there's this really cool one. This is called a function capsule, which I never remember that's what it's called. I call it something else. The function capsule. I'm going to call it volcano because that's what it looks like to me. It looks like a volcano. Here's the parent. F of x equals 1 over x squared. And really what it does is it literally looks like a volcano. Instead of the hook being here and in quadrant 1 and quadrant 3, you have a hook here in quadrant 1 and a hook here. Doesn't that look like a volcano? That's how I remember it. So what would I say is my domain for this one? How wide is this thing getting? Well, I still have an asymptote here at 0. So negative infinity to 0, 0 to infinity. The range changes for the capsule, obviously, because I don't have anything below the y equals 0 line. I have nothing there. So my range would be 0 to infinity. 0 on up is how tall this picture is getting. So that's called the function capsule. So now we're going to play around with this one. We're going to put, something next to the parent. We're going to add something on the outside. We're going to put a number on top. It's fine. We got this. We've done this before. There's nothing new. Graph and state the domain and range of y equals negative 1 over x plus 5 squared and then minus 3. And that negative 1 can be on top. Sometimes they put it on the outside. It's up to you. All right, so let's again kind of go over what all these parts are and what they mean. If you are a minus 3, you're going to go down 3. If you are a plus 5 inside the parent of the capsule of the volcano, you do the opposite, left or right. So this one I want to say right, but I'm going to go left 5. This negative sign, do you remember what a negative sign on the outside of a parent does? It flips it over the x-axis. So again, you could use your calculator, which I'll show you. I'll show you on the calculator what this looks like. But here's your graph. You are now down 3, 1, 2, 3. Make your horizontal line. Y equals negative 3. That's your horizontal asymptote. And your left 5, 1, 2, 3, 4, 5. That's your horizontal asymptote. Now, if it wasn't negative, I would make my volcano shape here and here. But because it's negative, I've now flipped it upside down. To look like that. Oh, and by the way, let's write this line. Vertical asymptote at x equals -5. Okay? So now let's state the domain and the range. So the domain, again, how wide is this thing getting? Well, it's covering the negative x-axis up until the vertical asymptote of -5. So it's going from -infinity to -5. And then we unite it with this part of the graph, which is from -5 to +infinity. So up until that vertical asymptote. The range, how tall is this thing getting? Well, the lowest point on the graph would be -infinity up until the horizontal asymptote. So -infinity to -3. But then I have nothing after -3. Nothing after -3. So let's just take a look at this on Desmos. Hopefully it works for me tonight. Please be kind. -1 divided by x plus 5 squared. See, there's that volcano. And then I move my cursor over and then I put -3. And there you go. You can see right here, they gave you a point. That was nice of them. Ooh, there we go. But this is at the point -3.04. But this is getting really, really, really close to the line -3, to the horizontal line of -3. And then this one, look, there's -5 right there. And that thing is volcano right down into it. Okay. When you type this into your calculator, and I'm going to show you that too, because I know some of you like Desmos, some of you like the calculator. When you type it into the calculator, I'd be really careful, especially something like this one. I might use the fraction button if you have the newer calculators, meaning like you go alpha y equals, and it gives you that n over d. And then you type -1 over parenthesis x plus 5 squared, and then move that arrow cursor over, and then put -3. And then do zoom 6. And you'll get that similar picture. The nice thing is on Desmos, it just kind of gives you certain, like, where does it hit the y-intercepts? It does y-intercepts and x-intercepts and stuff like that for us, but be careful. If you don't have that fancy fraction button like this one, if you have the old calculators, which I know some of you do, you just want to put like, let's see, you want to do -1. Let me take that back. You almost want to put it in its own parenthesis. You want to put a lot of parentheses. You want to put like -1 divided by parenthesis x plus 5 squared, and then close it. So like that's its own thing. -1 divided by parenthesis x plus 5 squared, and then put -3. If you don't have the fancy alpha y equals, because some people have the old calculators. That's why I'm trying to show it tonight. A lot of people. And then you hit graph, you'll get the same picture. You got to be really careful how you input it in to the calculator. All right. And shockingly enough, we're almost done with this lesson. This is a very short lesson. Yay, we missed short lessons. Yay for short lessons. Okay. So let's see, three quick examples here. This one says, use division, to rewrite the rational expression. and describe the transformations and graph. And here's what they gave you. F of x equals x minus 10 over x minus 11. Use division to rewrite this rational expression and describe the transformations in graphs. So I know most of you are really good with synthetic division. You can do that. I might do both right now. Let me think about that one. I think I'll do both. Here's what we're doing. We're saying we're dividing by this. So this number becomes the k. Remember, you want to change it to an 11. And then this would be the coefficients polynomial that I would use. So I would put a 1 here and a negative 10 there. And then remember, drop it down would be 1. Multiply would be 11. Add would be 1. That is your remainder. Now, how do you write this as a polynomial? Well, this would be 1, because right, this was a degree 1. So my next degree after degree 1 is degree 0, which really is a constant. So this is a constant 1 plus take your remainder and put it over what you divided by written as a factor. 1 minus 11. Whew, that works, but that is quite weird. I don't like doing it that way. I'm going to show you another way. I'm going to do it the long division way. So let's do this. You divide by x minus 11 divided into x minus 10. So if you have, if you have a, third, fourth grader, you know how to do long division. So here's just to refresh you what you do. You say, how does an x become an x? That's pretty easy. You multiply by 1. So take 1 and multiply by this whole quantity, and you get x minus 11. And then you subtract, because that's what you do in long division. And then your remainder is 1. And then what you write is this 1 plus 1 over x minus 11. And so now, how do we graph that? What does that mean? Remember, this is our function now. So let's talk about this. Okay, right here. Let's talk about this function. Well, if I'm inside the parent, I go right or left. So I'm going to go in the opposite. So it looks like negative 11, but I'm going to go right 11. If I'm outside the parent, I go up or down. So this is going to go up 1. So when I go to graph this, where am I going? Right 11. Wow. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make your little asymptote there. There's your vertical asymptote at x equals 11. Negative 11, sorry. Oops. X equals negative 11. I just went the wrong way, didn't I? I just went left. Sheesh. Ignore everything I just did. I just went till I don't even know my right from my left. And I even wrote it up here right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There we go. That's better. X equals 11. And then I got to go up 1. And so then I have y equals 1. So there's my horizontal asymptote. And there's my vertical asymptote. That's much better. And then I can put my hooks in there. And I would have caught on because, again, you're more than welcome to use the calculator or Desmos. So if I put this in my calculator, put the original function in. Let's see, let's put what the original function was. It was x minus 10. I'm going to put it in parentheses. Divided by x minus 11. I'm a little zoomed in right here. Yeah, there you go. See, I can see I'm all the way shifted to the right. So if I had graphed it wrong and shifted it to the left, and I checked myself on Desmos, I'm like, oh, I would have done something wrong. So nice way to easily check yourself. Okay. They have these two strange questions on homework that I was looking at. And I'm going to do them for you. I don't say they're strange. They're just an interesting way of doing the problem. So I kind of wanted to do this. Which graphs have a domain of negative infinity to 4 united with 4 to infinity, and choose all that apply? So they're going to give you like graphs, and bear with me as I draw them. Here's a capsule one, and we'll call this choice A. And here's a choice B. And then here's a choice C. 1, 2, 3, 4. 1, 2, 3, 4. And you got a hook here and a hook here. So here are your pictures. And the question is asking which of these graphs that are just drawn has a domain, that's the clue, from negative infinity to 4 united with 4 to infinity. If you remember what I just said from the beginning of class, that your domain is up to, stop Jack, thank you. It's up to the vertical asymptote. So that number right there is your vertical asymptote. It's that vertical line. So we should have this vertical line, a vertical asymptote at 4 is really what I'm looking for, at x equals 4. So if I'm looking at what they've given me, does this have a vertical asymptote at x equals 4? Yes, it does. So this has a domain from negative infinity to 4, 4 to infinity. So this one works. Does this one have a vertical asymptote at 4? No, this has a vertical asymptote right here, which is 0. It has a horizontal asymptote at 4, but that would be a range. So this doesn't work. Does this one have a vertical asymptote at 4? 1, 2, 3. Yes, it does. Right here. Vertical asymptote x equals 4. So again, my domain is from negative infinity up to 4, 4 to infinity. So this one also works. And you will have a question like that where you have to choose all of the ones that apply. So you may have not just one answer, you'll have multiple answers. So I wanted to make sure I showed you a problem like that one. And then one last one, also multiple choice. So bear with me as I give you the graphs. I had to draw them myself. My printer wasn't working, so I can't print it. Which graph has a single solution? This was interesting the way it was worded. Has a single solution to f of x equals -3. And I'll give you some pictures here again. So bear with me. 1, 2, 3. And this we'll call A. And this is 4, and here. And then this will be C. Just thought this one was a little bit different way of thinking about it, so I want to give you a moment to copy this down and understand which graph has a single solution to f of x equals -3. So this is where it got me. So when I was looking at this, f of x equals -3 is, again, it's a line. Y equals -3, horizontal line. Y equals -3. So if I go through each one of these pictures and I draw a horizontal line at y equals -3, which one has a single solution? Which one has one x? Meaning, which one crosses the x at one point? That crosses the x of the graph. So I go to graph this one. Let's say 1, 2, 3 is here, and I make my horizontal line. I have two x values at y equals -3. I have two solutions. So this one is not a single solution. 1, 2, 3. So y equals -3. I've gone through this point right here. Oh, that's a single solution. I'm not hitting any other x value. So this one has a single solution. This one, 1, 2, 3, all the way down here. There's nothing. I'm not even touching the graph. There's not even a solution for that one for y equals -3. So this one does not have a single solution. So I just wanted to show you that because I thought that was kind of different way that you have on your math lab. All right, well, that is 5.1. So we're going to take a little break. When we come back, 5.2 isn't too long.